Welcome back to Algebra 1 here with us at MPB. I'm so glad you came back. Today we are continuing with our functions that we've been working with. We are going to look at evaluating functions. Our standards that we're looking at today is IF2 and IF5. We have some can-do statements. I can find the range and domain for a given function. I can write a function that represents a real-world scenario or situation and evaluate functions for specific values. So let's go ahead and look at some review. We've done some of these in past lessons, but let's go ahead and look at some of these. It says, let M be the set of ordered pairs. M equals 0, -3, 4, 9, 2, 3, -1, 10. I need to know if this is a function or if it's just a relation. Now let's do a little recap. If it's a function, I'll have one x to one y. If it's a relation, I may have more x values represented. So when I look at these, x is 0, x is 4, x is 2, x is -1. So we can see that this is a true function. So let's make sure that we keep that in mind as we go through. It says function statements. If it costs a car manufacturer X amount of dollars for each vehicle they produce, the equation C of X equals 21,347X represents the total amount of producing or manufacturing a car at the factory. Complete the following statement for this function. Now, here is what we have. C of 4 equals 85,388. We need to know what that means. If we plug in this 4 to our given function, we find out that C of 4 equals 21,347 times 4. If you put this in your calculator, everybody put this in your calculator right now, 21,347 parentheses 4. What do you get? You're right, 85,388. So when I look at this function statement, let me see if I can interpret what it means. It's saying that for 4 cars, it costs $85,388 to produce them. That is how we are interpreting these equations with these functions. Now, football's in the air. A football is thrown from a quarterback to the receiver with an initial velocity of 10 feet per second. The quadratic function h of t equals -3.8 t squared plus 10t plus 4 represents the height from the quarterback above the ground in feet to where it hits the ground where the receiver misses it. So what it wants us to do is determine h of 2. So what I'm going to do is everywhere that I see a t, meaning 2 seconds, I'm going to plug in a 2 for the letter t in this equation. So let's write that and see what it looks like. H of 2 equals -3.82 squared plus 10 times 2 plus 4. This is straight calculator skills. I'm going to plug this exactly in my calculator, just like that, parentheses and all, and see what I get. So everyone now, plug this into your calculator and see what you get. Exactly right. I'm going to have where h of 2, meaning 2 seconds, equals my 8.8 feet. That's what I get. Now, we need to make sure that we can interpret these functions and the x and y values that can possibly be put into them. So let's see. Can -2 be an input for this? So over here in our passage, it gives me this height from the quarterback and it's above ground. So if I'm looking at inputs above ground, do you think my numbers are going to be positive or negative? They're going to be positive numbers. So if I have a negative number, where does that? That's below the ground. Now, can that quarterback throw below the ground? No, he can't. So -2 cannot. It cannot because -2 is below the ground. We need to make sure that we are putting these in our notes pages so we understand what these positive numbers mean and what these negative numbers mean when we put them into our function equations. Let's look at the next one. So I've got the same passage, but now I'm going to do some graphing. It says graph this scenario's function in your calculator or Desmos. Can we determine a reasonable domain and range for this scenario? This right here tells you everything that you need to know. So what I'm going to do is I'm going to use Desmos. I'm going to go ahead and plug in what my equation was from this previous football. So I can't use H and T in Desmos. I can't use H and T in my calculator, but I can use my X and Y. So what I'm going to do for my H's, I'm going to use my Y, and for my T, which is in parentheses, I'm going to use my X. So let's go ahead and put those in. So I'm going to have Y equals, and then I'm going to put in -3.8 parentheses X squared. Nope, not X squared, I'm sorry. I put the wrong number in. Well, all right. There we go. X squared, and then I'm going to have plus 10x. And then I'm going to add 4 to it. So I'm going to look right here and see when I put my equation in what it looks like. It's graphed as a parabola, okay? So here is where my football player would have been, right here, throwing my football. So at 0, 4 is where the football was originally thrown. So he throws it as an arc, and it reaches this height, and here is where the receiver dropped it. So what could I possibly do or think about this? I see where my y-intercept is, and I see my x-intercept, and I see the very top or the highest point of what my football would have been. Now it asked me, can we determine a reasonable domain and range? So let's go back and look. So if I had it and it looks something like this, where this is 2 and this is 1 and 0, 1, 2, 3, 4, and we said that one was 10 and some change, what would be a reasonable domain? Now remember, my domain deals with what values? Exactly right. It deals with my x values. So what do you think, by looking at this graph on my board, looking at your graph on your Desmos or your calculator, what could we say a reasonable domain would be? So my domains start with 0, and they go where? All the way to 2. That could be the interval. There's a key word that we've heard before. That could be the interval of my domain. Now let's look at my ranges. What did we say that my range deals with? It deals with my y values. So I know that my y values hit the ground at 0. But what was the highest above the ground that it was? Yes, so I would say about 10 feet. So those are possible domain and range intervals, and those are key words that we got to make sure that we remember. All right, let's look at the next one. Now, let's try and do some practice. All right, we're going to do these together. So it says, if you are given the function f of x equals 5x plus the square root of x squared plus 25, what do you find as the output of f of 12? Now remember, this output means my y value. So what I'm going to do is I'm going to tap into Desmos to help me, and I'm going to pull a table. So let's go to Desmos and let's put this in. Remember, can't put f's, can't put anything in Desmos but y's and x and y. So let's go ahead and plug that. F of x is also known as y equals, then I have 5x plus the square root, parentheses, x squared plus 25, close my parentheses. So now I've put in my function, it's pulled this graph. Now I could go over and find where my x is 12 and then go all the way up and keep on going and keep on going and keep on going, but I may miss a point. So what I'm going to do is I'm going to pull a table. Now you're probably asking, how do you pull a table on Desmos? Good question. Everybody on your Desmos sees the gear. I'm going to press my gear. When I press that gear, I see a table. There's my table on Desmos. Now, Ms. Killen, I don't want to know -1 or 2. I need to know what my output is for 12. Well, right here, I'm going to put 12, and it gives me what my y value is. So now we've just changed the game. I can put my functions in Desmos, and I can pull a table to find all of my possible outcomes for a specific input. Ms. Killen, what if I had a fraction? What if I wanted to know maybe 2/3? That's a good question. So let's go here and put 2/3. Well, I don't see a fraction. Yes, you do. 2 divided by 3. And there's my output. Any type of number, rational or irrational, that you can think of, we can pull it on the table. This is a very big piece that we can use on that end of year test. So we need to make sure that we are understanding how to use these different functions. Let's go back to our problems now. We talked about how to do Desmos. Now let's look at how we do this with the calculator. So let's go ahead and look at this at the calculator. This calculator should be very similar to the one you're using. So what I'm going to do is I'm going to put that same function in my calculator. I'm going to go to my y equals function. So I've got my y equals. Now let's put in that same function. 5x plus the square root, parentheses, x squared plus 25, close parentheses. So I've plugged it into my y equals function. Let's go ahead and look at that graph to make sure it graphed the same. So I'm going to hit my graph function, and I've got to put my x. I'm going to hit that graph function, and it looks very similar to what we saw on Desmos. Now, Ms. Killen, on here, I really can't see where that x equals 12. So let's pull a table on my calculator. To pull a table on this calculator, I'm going to look up here above the word graph, and there's a blue word that says table. Anything on these calculators that's in blue, I'm going to hit the second button. Anything on these calculators that's in green, I'm going to hit the alpha button. So since my table is blue, I'm going to hit second table. There's my table. I'm going to scroll down to where my x is 12, and I get the same thing as 73. Now, one thing about my table in my calculator, which is different than the table on my Desmos, is I have a hard time finding my fractions in my decimal numbers. So if you're looking for those whole numbers, you might want to pull the table on your calculator. But if you need more of those smaller numbers or those mixed numbers, you might want to pull a table on your Desmos. All right, let's go back and look at some more problems. So now that we've looked at calculator skills and Desmos skills for these different types of problems, now let's look to see if we can answer some questions about these. It says we are given a rule for a function. P of x equals 7 plus x. Determine if the following are true or false statements. This is a very good time for you to practice that Desmos and calculator skill. So pause the video, go ahead and work these. Plug in your inputs and see if you get the outputs, what they say, and then we're going to see if it's true or false. All right, so now that we have had an opportunity to look at these, when you put -9 in as your input or you pulled a table, did it come to equal 4? Is that true or false? It is false. It did not equal 4. Now when we looked here at this next one, we had to find the value of P of 1 to see if it was larger than P of -6. Was that true? Absolutely. Now for the next one, we have P of 0 equals a -7. Now when I pulled that table, I did not get a -7. So when I looked on that table and I saw my output for 10 and my output for 4, was 10's output smaller than 4's output? No, it wasn't. So this was a very good problem to help us determine how to use those tables and how to use Desmos and calculator skills. Very good problem. Now it's time for us to master. We've had the problems, now it's time for us to master. Go ahead and pause this video, read the problems, and you and your table partners see if you can work these, making sure that you write your work on your table, or if you don't have those tables that you can write on, that you write on your notes. All right, so now that we have worked together, let's see if you can give me your answers. Determine what the value would be for W of 4 for this function. Now remember, everywhere in this function that I see an X, I'm putting a 4. So what would the value of W of 4 equal? Exactly right. It's going to be 14. Awesome. Another way, if I didn't want to plug that into my calculator, I could just plug it into my Y equals feature, pull a table. There's so many ways that we can answer these functions. So let's look at the next one. It says the length of a special pizza box is 3 inches longer than its width, 5 times its height. Write the function that would model the volume of this pizza box where W is the width in inches. Now, with this type of problem, we had to have back knowledge about volume to work this. Now remember, when I do volume, I have length times width times my height. So let's go ahead and plug in what we know. My length, it says, is my width plus 3. The width of this box is just the width. And the height is 5 times. So if I'm writing the height in terms of width, I'm going to have to reverse that and do some division. So it would be W plus 3 divided by 5. So then if I write this whole function, it's going to look like this. W plus 3 times W times W plus 3 over 5. So then this bottom question asks me, find the volume of 8. What does this mean? So if my width was 8, what would my whole volume be? Now, I can put this in Desmos, and I can put this in my calculator, making sure I use the X and Y values instead of V and W. So then if I plug that in and pull a table, Or simply put 8 everywhere I see a W. What did you get? So did I. I got 193.6 inches cubed. Ms. Killen, I didn't have that inches cubed. Why did you put that? Because volume is a three-dimensional measurement. So you have to label your numbers. If I'd put 193.6, I don't know if we're talking about pencils, I don't know if we're talking about pizza slices. So you have to label your numbers. Always, always, always. Now, let's not forget, just because it's a relation does not mean it's a function. My domain is all my x values or what your input is. My range is my y values or what your output is. I am so glad that we had an opportunity to learn about these functions. I am so excited for what's coming next. Thank you so much for coming to learn here with us at MPB.